So there's, just like there's a finite arithmetic series and there's an infinite arithmetic series, there's a finite geometric series. So the formula for a finite, so it means it stops, series that's geometric, is the sum is the first term times 1 minus r, which is a common ratio, to the n, which is the number of terms, over 1 minus r, where r is the common ratio and n is the number of terms. Now you can also have an infinite geometric series. So an infinite geometric series can either converge, which means it gets down to a number, a sum. The sum gets to an actual number. Or diverge, which means it approaches no limit or it doesn't actually reach a number. So I'm going to have a converging situation where there's actually an answer, or a diverging. So to converge means that the absolute value of r, which is the common ratio, is less than 1. And if it diverges, the absolute value of r is greater than or equal to 1. So an example would be if you have the sequence 2, 4, 8, 16, and you add the series, adding those up, you're not going to ever get to a specific number. So it's going to diverge. However, if you had something like this, 1 plus 1/2 plus 1/4 plus 1/8, that actually gets to a number. So an example of that would be if this is 1, and then you're going to add a half, then you're going to add a fourth, then you're going to add an eighth, then you're going to add a 16th. See how this is like, it keeps going infinitely? It's actually going to converge to 2. So it's kind of weird thinking that an infinite series could converge to a number, but it can, and there's a geometric example of it. So in this first part, figure out whether the series converges or diverges. So what I'm just going to do is figure out what r is. So in this case, r is 3. So that means it diverges because the absolute value of that is greater than 1. Now the second one, I can tell it's an infinite because it has the infinity on the top. So if I do the first term, if I plug in 1, it's 2/3. If I plug in 2, it's going to be 4/9 because 2 squared is 4 and 3 squared is 9. And so now I can find the common ratio. So 4 divided by 2 is 2. So the common ratio is 2/3. This is less than 1, so it converges. So the formula is, I should have wrote that at the top, is if it converges, the formula is, it's very simple. It's the first term divided by the difference of 1 and the common ratio. So in this case, my first term is 2/3. And I'm going to do 1 minus the common ratio, which is 2/3. So to simplify this, it's going to be 2/3 divided by 1 minus 2/3 is 1/3. So I'm going to flip the fraction over and multiply, so by the reciprocal. So multiply the top and the bottom by 3/1, and you get 6 divided by 3, which is 2. So this converges to the number 2. Okay, let's check number 3. So 3, find the common ratio. 1/5 divided by 1 is 1/5. So it converges. So now I'm going to do the formula, which is a sub 1, which is 1 over 1 minus the common ratio. So this is 1 over 4/5, because 1 minus 1/5 is 4/5. And then when you divide fractions, you flip this one over. So this is going to be 5/4 is to evaluate the series. Okay, number 4. Find the common ratio first to see if it converges or diverges. And the common ratio is 2, so this diverges. So you can't calculate the sum. And then number 5, divide this, you get r equals 1/2. So this would be, it converges to a number. So now you can actually calculate the you can evaluate the series. So I'm going to do a sub 1, which is 1/2, over 1 minus, oops, a sub 1 was not 1/2. I don't know why I wrote that. Okay, so a sub 1 was the first term, which is 1 minus 1 over the common ratio, which is 1/2. So 1 divided by 1/2 is 2. And then number 6, the common ratio is -3/2 divided by +3. So this is -3/2 times 1/3. So this common ratio is -1/2. So the absolute value of this is less than 1, so this converges, so I can actually calculate the series, or I can evaluate the series. So a sub 1 is 3, so it's 3 divided by 1 minus r, and r is -1/2, so just be careful that you put that -1/2. So this is going to be 3 over 1 plus 1/2 is 1.5, or I'm going to write it as 3/2. So now you have 3 times 2/3, so this still converges to 2. And then down here, the weight at the end of a pendulum, so a pendulum looks like this, something's at the end swinging, swings through an arc of 30 inches on its first swing. So the first time this is 30 inches. After that, each successive swing is 85% of the length of the previous swing. What is the total distance covered by the swing by the time it comes to rest? So you're swinging, 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 back and forth. So this is going to have an infinite number of terms. We're going to use the infinite sequence. Infinite geometric series formula. So I'm going to do, because hypothetically it would never stop. You do the same thing if you were dropping a basketball, up and down and up and down and up and down and up and down. So I'm going to do a sub 1 over 1 minus r. So a sub 1 is the first arc length. And then my r is 0.85, and it's definitely converging because that absolute value of that number is less than 1. So it's going to be 1 minus 0.85. So I'm going to calculate that. That's going to turn into 30, or that's going to be 30 divided by 0.15. So 30 divided by 0.15 is 200 inches. So it's going to travel 200 inches back and forth until it finally comes to a stop. The Geyser family starts saving for a family vacation that is 1 year away. They start with $125 the first month. Each month they save 8% more than the previous month. How much money will they have saved 12 months later? So because we have a limit of 12 months, you're going to use the finite geometric series formula. So a sub 1 times 1 minus r to the n over 1 minus r. So a sub 1 is what you start out with, 125, 1 minus. So if you save 8%, that r is 0.08. But it's going up, so it's 1.08. Because it's 8% more. So this is going to be 1 minus 1.08. And I don't leave much room in here, but I'm going to put to the 12th power. So 12th goes on the inside, just ran out of room. And then over 1 minus r, which is 1.08. So just be careful that when you're putting this in your calculator, that you're keeping this denominator in the parentheses. So what I don't want you to do is do this in your calculator and then divide it by 1 and forget to put divided by 1 minus 1.08. So you should definitely not get a negative number. So put this in your calculator, and when you do, you get approximately $2,372.14, because I rounded to the nearest 2 decimals because we're talking about money. Okay, then number 9, identify a sub 1, which is the first term, r means the common ratio, and n is the number of terms for each series. Then evaluate the series. So remember, evaluate the series means actually add it up. So a sub 1 in this one is negative 45. R is the common ratio. So to find R, I'm going to do 135 divided by negative 45. And R is negative 3. So I did this divided by this. And then the N is the number of terms. So it has 5 terms. So you can use the geometric series, the finite formula, but there's only 5 terms, so I'm just going to add them up. So negative 45 plus 135 plus negative 405 plus 1215 plus negative 3,645 is negative 2745. Okay, then same with this one. I'm going to do a sub 1 is the first term, it's 1/3. The common ratio is 1/9 divided by 1/3, which is the same thing as 1/9 times 3 over 1, so that's 3/9, which is 1/3. And the number of terms is 4. So with this one, I just think it's faster if you just add up all the fractions. So I'm going to make a common denominator of 81. So 1/3 is 27 over 81 plus 1/9 is 9 over 81 plus 3 over 81 plus 1 over 81. So if I group these up, this is 30 plus 10 is 40, so it's 40 over 81.